Hi friends, welcome to Civil Learning Library for the topic weld capacity. In this presentation, we will see the weld capacities based on AISC code. First, we will see fillet weld strength as per AISC 2010 table J2.5 ASD method. Here we listed three grades, grade 50, 275 and 36. We will see grade 50 as an example here. So for grade 50, yield strength value is 345 Newton per ohm square. Factor of safety is 1.5. You can see this tabular column table J2.5 for shear. For base metal, factor of safety is governed by section J4. So as per section J4, the factor of safety is 1.5. So the final base metal strength is 345 divided by factor of safety, which is 230 Newton per ohm square. Then we will see the values for weld metal strength. For weld metal strength, the formula is 0.6 FEX, which is taken from this same table, 0.6 FEX, zero point 0.6 into, here I am assuming 480 electrodes, so I am putting those value. This 480, which is equal to E70 KSI, divided by, we have to multiply divided by factor of safety 2, which also divided in this same tabular column. So the final value is 144. Then the strength controlled by base or weld, we have to take the least of these two values. So here base is 230 and weld is 140, so we have to take the weld value. Then we have to multiply this least value with the effective throat thickness. So you can see this image here. So this is the normal fillet weld image. So this A is nothing but the design throat thickness and this is the leg length. So we have to find out this effective throat thickness. So this cos 45 degrees. So the cos 45 degree value is 0.707. So if you are multiplying this leg length into 0.707, then we will get this throat thickness value. So the final value is this 144 into this effective throat value. We will get final tensile strength of the fillet weld, which is 101.8 Newton per ohm square for ASD method. And you can see grade 275 and grade 36. Here the governing condition is always weld metal. So for fillet weld, the governing metal always will come weld metal only, and for CJP or PJP, maximum case the governing condition is base metal. Here in this table, we listed same fillet weld strength, but only the changes instead of ASD, here the LRFD values are provided. Uh, so here FOS is 1 for LRFD method based on this reference J4.1. And for the weld metal strength, the factor of safety is 0.75 based on this tabular column. You can see here. So other things are remain same. Here the base metal value is 345 and weld metal strength value is 216. So we have to choose the least one. So here also the weld metal strength is least one. Then this 216 we have to multiply with the effective throat value 0.707. Then we can get the final tensile strength of the fillet weld for LRD method, which is 152.7 Newton per mm square. Here I listed some one example. We will assume that this B value is 6 mm. Our weld leg length is 6 mm. Then the effective throat thickness is 0.707 into 6, which is 4.2 mm. And we are welding this as 200 mm length. Then the strength of the weld will be this effective throat thick 4.2 into length of the weld into the tensile strength of the weld, which is 152.7 Newton per ohm square. So the weld strength is 128 kilonewton. So all formulas are here, all this factor of safety and these all values are calculated based on this table J2.5. Here the headings also given, fillet welds including fillets in holes and slots and skewed T-joints. For shear, they given base, it should be governed by J4. From J4 only we took this factor of safety, and for weld we are using this factor of safeties. And tension or compression parallel to weld axis also. Here they given the note, tension or compression in parts joined parallel to a weld need not be considered in design of welds joining the parts. If it is parallel, generally it won't carry the load also. Next, we will see the weld strength for the PJP weld, which is partial joint penetration weld. So for partial joint penetration weld, this is the values provided in table J2.5. We will see the condition tension normal to the weld axis. So here also we listed three grades, grade 50, 275 and 36. So we will see for grade 50. Here we have to compare with FU instead of FI. So ultimate strength of grade 50 is, here I am assuming 450 Newton per mm square. FOS is 2. Here it is given for base also. So 2 we have to use it. So base metal strength is 450 by 2 is 2225. For weld metal strength, You can see the formula, same formula, 0.60 FEX. So 0.6 into 480 divided by factor of safety for weld is ASD method is 1.88. So raising 1.88. So the final value is 153. So here also we have to take the least one, base metal and weld strength. So here weld is least, which is 153 Newton per mm square. So this is applicable for all three grades also. If you divided by factor of safety, we will get at least one is weld metal strength only. Same thing we will for we'll see for PJP weld shear strength. For shear strength also three grades comparison provided here. We will see for grade 50 yield strength of the value is 345, FOS is 1.5. For shear you can see here for shear different factor of safety is uh, provided here. For base is governed by J4 as by J4. For shear yielding the factor of safety is 1.5, and for so final base model strength is 138. Here for shear we have to multiply with zero point 0.6 always for PJP and CJP. Then coming for weld metal strength, the formula is 0.6 FEX. So 0.6 into 480 divided by factor of safety is 2. So which was equal to 144. So you can see here the governing always is coming as base metal. So the final value is 138 Newton per mm square. For grade 275 also the governing is base metal, and grade 36 also the governing is base metal strength. Yeah, here also we are seeing the PJP weld strength only. For LRFD method, for the conditions are same, only the FOS is changing for the LRFD method. As for LRFD method, the factor of safety is, you can see, tension normative weld axis. For base metal it is 0.75, so we used 0.75, and for weld factor of safety is 0.8, so that factor of safety used, and the final tensile strength value for LRFD value is 230 Newton per mm square, list of base and weld metal. Coming to shear also, the factor of safety is 1 based on the J4 section. And for the weld metal, the factor of safety is 0.75. So that same factor of safety used. And the final value is 207 Newton per mm square for grade 50. And here also the governing is base metal for the shear strength of partial joint penetration weld. This is the image for the partial joint penetration weld. This effective throat is nothing but this total weld depth minus some. Normally we are keeping this length as 3 mm, so it will vary, it's not constant. So that's why we didn't explain these values here. Next we will see the complete joint penetration weld, which is CJP weld. Here this is the values provided in table J2.5 from AISC for the complete joint penetration groove welds. For the condition we will see tension normal to the weld axis. Strength of the joint is controlled by the base metal. Here the strength is fully controlled by the base metal, so we no need to check the metal strength of weld. So here also three grades are listed. We will see for grade 50 yield strength of the material is 345, FOS is 1.67, and our final base metal value is 207 Newton per mm square. So weld metal strength here no need to check based on this condition. So always strength controlled by base. So our final tensile strength value is 207 Newton per mm square. So for grade test 275, the value is 165. For grade 36, the tensile strength value is 150 Newton per mm square. Same thing here listed for the CJP weld shear strength. So here the factor of safety for shear strength is 1.5 based on this reference J4 4.1. So final base metal value is 0.6. We have to multiply for shear. So 0.6 into 345 divided by factor of safety, which is 138 Newton per mm square for grade 50. For grade 275 which is 110, and grade 36 which is 100 Newton per mm square. This is the sample image of groove weld or complete joint penetration weld. Here also we are seeing CJP weld, but for LRD method, there is no changes except the factor of safety. So factor of safety value is 0.9 for tension or compression strength of CJP weld. So the tensile strength value is 310.5 Newton per square for grade 50. For grade 275 to 47.5. For grade 36 to 25 Newton per square. Same thing for shear strength for complete joint penetration weld. Factor of safety value is 1. So for grade 50, the shear strength value is 207 Newton per ohm square. Grade 275, 165 Newton per ohm square. For grade 36, 150 Newton per ohm square is CJP weld strength. Hope this video is helpful, and thank you for watching the presentation. Please like and subscribe to get more videos and updates.